When we talk about powers and roots, we want to keep in mind that when we have repeated addition, 3 plus 3 plus 3 plus 3, we can rewrite that as multiplication. So we have 3 4 times, or 4 3s. When we have repeated multiplication, however, we can write that using powers. So repeated multiplication can be expressed as this being 4 to the third power, giving us 64. So when we have powers, the 3 right here is going to be called the base, and this 2 is going to be called the power, also called the exponent. And so one of the greatest conundrums when it comes to integers and exponents is whether these 3 values we have here are equivalent to 16 or negative 16. And in order to sort that out, we are going to look at this problem right here, 19 minus 4 squared. Hopefully it immediately comes to mind that you're going to follow your order of operations, and you're going to square the 4, and you're going to get 19 minus 16, and this becomes a 3. So if we feel certain about that, then now I want you to look at this problem, and we are going to do our keep, change, change technique. So we're going to keep the 19 the same. We're going to change the subtraction to addition of the inverse. So now what we have is I want us to zoom in right here. We now have negative 4 squared. We know that changing things to addition of the inverse is not illegal. It's totally fine. So we know that we didn't do anything wrong here. And we also know that this, therefore, is exactly the same, and so it has to be equivalent to 3. And so that means that the negative 4 squared has to be equal to negative 16, which seems so strange because we know a negative times a negative gives us a positive. But what you have to realize is in this situation, you have to think of this as the opposite of 4 squared. So this is going to be equivalent to negative 16. This one right here, yes, that is a negative 4 times a negative 4. So this becomes a positive 16. And then this one here has the negative on the outside of the parentheses, so you again get a negative 16. The hardest one, though, is this one. And so what I want you to think of that as is it's the inverse of 4 squared. Think of it as like negative ... 4 squared. Or in other words, you have negative 4 squared. This exponent can control the 4, but it cannot reach all the way to the negative sign. That power cannot powerize that negative sign. That negative is like, nah, 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 sticking out his tongue like, ha, 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 you can't get me, what? So, let's practice. Let's determine the values of these and be cautious about which ones are positive and which are negative. Whoops, I went in the wrong order. 6 squared, fair enough, 36. Number 2, the inverse of 7 squared. So think of that as the inverse of 7 squared. So that would be a negative number. Number 3, the inverse of 8 squared. Number 4, this is negative 4 in parentheses. So the squared powerness can reach both the negative and the 4. So you get a positive 16. Here we get a 4, and here we get a negative 9. Now let's talk taking the roots. If exponents are repeated multiplication, you might consider roots as repeated division. Taking the square root of 4 is saying what times itself will give me 4, and that answer is a 2. The cube root of 8 is something times itself. 1, 2, 3 times needs to give me 8, so that value is 2. The cube root of 27 will be 3, and the square root of 81 is 9. Now, to review in terms of vocabulary, this is a radical. The number that goes right here is the index, and that indicates how many parts you're trying to separate into, how many factors of the same type. And then this right here is going to be the radicand. So in this situation, the 3 is the index, the 27 is the radicand.